Good morning everyone. Welcome to Nidhi's Maths Room. Today I am going to discuss about Euler's function or Euler's 5 function. So what is meant by an Euler's function or Euler's 5 function? See here the mathematical definition of the Euler's function is for any positive integer n, Euler's function is denoted as phi of n. The Euler's function is denoted as phi of n and is defined as the number of positive integers. The number of positive integers relatively prime to n and less than n. Please understand the definition of Euler's function. The number of positive integers relatively prime to n and less than n. So I give one example. I think it helps to understand the definition of Euler's function. So see here, first I take the number 12. Let us take n is equal to 12. The numbers which are relatively prime to 12 are, the numbers means the integers. The integers relatively prime to 12 are 1, 2, 3, 4 are not prime to 12 because 2 divides 12, 3 also divides 12, 4 also divides 12. Next, 5 is relatively prime to 12, 7 is relatively prime to 12, 8 and 12 are commonly divided by 2 and 4. So, next 9 and 12 are commonly divided by 3. Next 10 and 12 are commonly divided by 2. So 11. 1, 5, 7, 11 are relatively prime to 12 and less than 12. Is it clear? So see here once again, 1, 5, 7, 11 are relatively prime to 12 and less than 12. ಅರ್ಥ ಆಗ್ತಾ ಇದೆ ನಾನು ಹೇಳ್ತಿರೋದು? So there are phi of 12 is equal to 4. There are 4 integers relatively prime to 12 and less than 12. ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ, ಎಷ್ಟು ಇಂಟೀಜರ್ಸ್ n ಗೆ ರಿಲೇಟಿವ್ಲಿ ಪ್ರೈಮ್ ಆಗಿರುತ್ತೆ ಜೊತೆಗೆ ಅದಕ್ಕಿಂತ ಕಮ್ಮಿ ಇರುತ್ತೆ, ಅದನ್ನೇ ನಾವು ಆಯ್ಲರ್ಸ್ ಫಂಕ್ಷನ್ ಅಂತ ಹೇಳಿ ಕರೆಯೋದು. ದಟ್ ಮೀನ್ಸ್ ಆಯ್ಲರ್ಸ್ ಫಂಕ್ಷನ್. ಇಸ್ ಇಟ್ ಕ್ಲಿಯರ್? ಅರ್ಥ ಆಯ್ತಾ ಎಲ್ಲರಿಗೂ? ಸೊ ಅದನ್ನ ನಾನು ಮ್ಯಾಥಮೆಟಿಕಲ್ ಡೆಫಿನೇಷನ್ ಹೇಳಿರೋದು. ಫಾರ್ ಎನಿ ಪಾಸಿಟಿವ್ ಇಂಟಿಜರ್ n, Euler's function phi of n is defined as the number of positive integers relatively prime to n and less than n. Number of positive integers relatively prime and less than that number is nothing but an Euler's function. Is it clear? Okay. Move on to the theorem on Euler's function. That is, the first theorem is, if p is a prime and k greater than 0, then phi of p power k is equal to p power k into 1 minus 1 divided by p. That can also be written as p power k minus p power k minus 1. If we take p power k as common, same ide namage barutte. ಅರ್ಥ ಆಯ್ತಾ? So the proof of this theorem is, it contains the theoretical part. So ಹಾಗಾಗಿ ನಾನು ಮುಂಚೆನೇ ಬರೆದ್ಬಿಟ್ಟಿದ್ದೀನಿ. The proof of this theorem is, if k is equal to 1, then the integers less than p and relatively prime to it are 1, 2, 3, so on p minus 1. Therefore phi of p is equal to p minus 1. What it represents? ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ. Here p is a prime number. p is a prime number. ಇಲ್ಲಿ phi of p power k ಅಂತ ಹೇಳಿದಾಗ k is nothing but 1 ಅಂತ ಹೇಳಿ ಚೂಸ್ ಮಾಡ್ತಾ ಇದೀನಿ. ಹಾಗಾಗಿ ನಮಗೆ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, phi of p ಅಂತ ಆಗುತ್ತೆ. Phi of p means what? Phi is an Euler's function. Phi of p ಅಂತ ಹೇಳಿದ್ರೆ the number of integers relatively prime to p and less than p. Relatively prime to p and less than p. So here p is a prime number. ಪಿ ಪ್ರೈಮ್ ನಂಬರ್ ಆಗಿದೆ ಅಂದಾಗ ಆ ಪ್ರೈಮ್ ನಂಬರ್ಗೆ ರಿಲೇಟಿವ್ಲಿ ಪ್ರೈಮ್ ಮತ್ತೆ ಪ್ರೈಮ್ ನಂಬರ್ಗಿಂತ ಚಿಕ್ಕದಾಗಿ ಬರುವಂತ ನಂಬರ್ಸು ಪಿ ಮೈನಸ್ 1 ಆಗಿರುತ್ತೆ. ಅದು ಹೇಗೆ ಸರ್? ಐ ಟೇಕ್ ಒನ್ ಎಕ್ಸಾಂಪಲ್. ಸಿ ಹಿಯರ್ 5 of 7 ಬರೆಯೋಣ. ಅಂದ್ರೆ ದ ನಂಬರ್ಸ್, ದ ಇಂಟಿಜರ್ಸ್ ವಿಚ್ ಆರ್ ಲೆಸ್ than 7 and relatively prime to 7 are 1 is relatively prime with 7, 2 is relatively prime with 7, 3 is relatively prime with 7, 4 is relatively prime with 7, 5 is relatively prime with 7, 6 is also relatively prime with 7, 1, 2, 3, 4, 5, 6. 6 digits are relatively prime with 7 and less than 7. That is nothing but 5 of 7 can also be written as 5 of 7 can also be written as 7 minus 1. Same as it is. 5 of p is nothing but p minus 1 ಅಂತ ಹೇಳಿದಲ್ವಾ. If p is prime, then 5 of p is equal to p minus 1. Like that, 5 of 7 is equal to 7 minus 1. ನೋಡಿ, ಇಲ್ಲಿ ಇದೇನಾರ ಪ್ರೈಮ್ ನಂಬರ್ ಆಯ್ತಂದ್ರೆ ಅದಕ್ಕಿಂತ ಕಮ್ಮಿ ಬರುವಂತ ಪ್ರತಿಯೊಂದು ನಂಬರ್ ಕೂಡ ರಿಲೇಟಿವ್ಲಿ ಪ್ರೈಮೇ ಆಗಿರುತ್ತೆ. ರಿಲೇಟಿವ್ಲಿ ಪ್ರೈಮ್ ಅಂದ್ರೆ ಏನು? ಎರಡೂ ನಂಬರ್ಸ್ ಕಾಮನ್ ಆಗಿ 1 ಇಂದ ಮಾತ್ರ ಡಿವೈಡ್ ಆಗಬೇಕು ಅಂತ. ಪ್ರೈಮ್ ನಂಬರ್ ಆಯ್ತು ಅಂದ್ರೆ ಅದಿನ್ಯಾವುದಾದ್ರು ಬೇರೆ ನಂಬರ್ ಇಂದ ಡಿವೈಡ್ ಆಗಕ್ಕೆ ಸಾಧ್ಯನೇ ಇಲ್ಲ. ಬಿಕಾಸ್ ಪ್ರೈಮ್ ನಂಬರ್ ಅಂದ್ರೆ ದ ನಂಬರ್ ವಿಚ್ ಇಸ್ ಡಿವಿಸಬಲ್ ಬೈ 1 ಅಂಡ್ ಇಟ್ಸ್ 1 ಮತ್ತೆ ಅದರಿಂದ ಮಾತ್ರ ಡಿವೈಡ್ ಆಗೋದು ಅಂತ. ನೀವು ಯಾವುದೇ ಪ್ರೈಮ್ ತಗೊಂಡ್ರೆ 7 ತಗೊಂಡ್ರೆ ಅದು 1 ಇಂದ ಮತ್ತೆ 7 ಇಂದ ಮಾತ್ರ ಡಿವೈಡ್ ಆಗುತ್ತೆ. ಹಾಗಾಗಿ ಇನ್ ಮಧ್ಯದಲ್ಲಿ 7 ಗಿಂತ ಕಮ್ಮಿ ಬರುತ್ತಲ್ಲ ನಂಬರ್ಸ್ಗಳು, ಅದ್ಯಾವುದ್ರಿಂದನೂ ಕೂಡ 7 ಡಿವೈಡ್ ಆಗದೇ ಇಲ್ಲ. ಹಾಗಾಗಿ ಎಲ್ಲವೂ ಕೂಡ 7ಗೆ ರಿಲೇಟಿವ್ಲಿ ಪ್ರೈಮೇ ಆಗಿರುತ್ತೆ. ಈಗ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ನೀವು 11 ತಗೊಳ್ಬಹುದು. 11 ನ ತಗೊಂಡು ನೀವು ಬೇಕಾದ್ರೆ ಚೆಕ್ ಮಾಡಿ. 11ಗೂ ಅಷ್ಟೇ 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They are all relatively prime with 11. Because 1 ಇಂದ 10 ತನಕ ಏನ್ ನಂಬರ್ಸ್ ಹೇಳಿದೆ ಅದರಲ್ಲಿ ಎಕ್ಸೆಪ್ಟ್ 1 ಇನ್ಯಾವುದೂ ಕೂಡ 11 ನ ಡಿವೈಡ್ ಮಾಡಲ್ಲ. ಅರ್ಥ ಆಗ್ತಾ ಇದೆಯಾ ಹೇಳ್ತಿರೋದು? ಹಾಗಾಗಿ ಸಪೋಸ್ p is prime, then 5 of p can be written as p minus 1. ಅದನ್ನ ನಾನು ಇಲ್ಲಿ ಹೇಳಿರೋದು. If k is equal to 1 means if we substitute k is equal to 1 for this, that gives 5 of p. 5 of p ಆಗುತ್ತೆ. ಹಾಗಾಗಿ then the integers less than p, the integers less than p and relatively prime to p are 1, 2, 3, so on p minus 1. ಅದಕ್ಕಿಂತ ಒಂದು ಕಮ್ಮಿ ಏನ್ ಬರುತ್ತೋ ಅದೆಲ್ಲವೂ ಕೂಡ p ಗೆ ರಿಲೇಟಿವ್ಲಿ ಪ್ರೈಮ್ ಆಗಿರುತ್ತೆ. ಅದನ್ನ ಹೇಳಿರೋದು. ಅರ್ಥ ಆಯ್ತಾ? ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಕಾನ್ಸೆಪ್ಟ್ ನೋಡಿ. ಇಫ್ k is greater than 1, suppose this k is greater than 1, then p, 2p, 3p, so on p power k minus 1, pk are all divisible by p. ಅವೆಲ್ಲವೂ p ಇಂದ ಡಿವೈಡ್ ಆಗುತ್ತೆ. among the integers 1, 2, 3, so on p power k, 1, 2, 3, so on p power k ಅಂತ ಹೇಳಿ ನೀವು ಎಲ್ಲ ಇಂಟಿಜರ್ಸ್ ನ ಬರೆದ್ರೆ p ನ ಮಲ್ಟಿಪಲ್ಸ್ ಏನೇನಿರುತ್ತೆ ಅದೆಲ್ಲದೂ ಕೂಡ ಡಿವೈಡ್ ಆಗೇ ಆಗುತ್ತೆ p ಇಂದ. ಈಗ ನೀವು ಯಾವ್ದಾದ್ರು ಒಂದು ಇಂಟಿಜರ್ ನ ತಗೊಂಡ್ರೆ ಅದ್ರ ಮಲ್ಟಿಪಲ್ಸ್ ಏನೇನಾಗಿರುತ್ತೋ ಅವೆಲ್ಲವೂ ಕೂಡ ಆ ನಂಬರ್ ಇಂದ ಡಿವೈಡ್ ಆಗೇ ಆಗುತ್ತೆ. ಸೊ thus the set contains exactly p power k minus 1 integers which are relatively prime to p power k. ಸೊ ಹಾಗಾಗಿ ಸೆಟ್ ಅಲ್ಲಿ ನಮಗೆ p power k minus 1 ಅಷ್ಟು ಇಂಟಿಜರ್ಸ್ ರಿಲೇಟಿವ್ಲಿ ಪ್ರೈಮ್ ಟು p power k ಆಗಿರುತ್ತೆ. ಸೊ 5 of p power k is equal to p power k minus 1. If we take p power k as common, that gives 1 minus p power minus 1. So p power minus 1 in the sense 1 divided by p. ಸೊ ಇದನ್ನು ಕೂಡ ನಿಮಗೆ ಒಂದು ಎಕ್ಸಾಂಪಲ್ ಕೊಡ್ತೀನಿ, ಆಗ ನಿಮಗೆ ಇದು ನೀಟಾಗಿ ಅರ್ಥ ಆಗುತ್ತೆ ಅಂತ ನಾನು ಅನ್ಕೊಂಡಿದ್ದೀನಿ. ಸೊ ನೋ ಡೌಟ್ 2 is a prime number, is it? ಸೊ 2 ಕೂಡ ಪ್ರೈಮ್ ನಂಬರ್. ನಾನು 2 power 4 ನ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀನಿ. 2 power 4 is nothing but 16, is it? ಓಕೆ, ಸೊ ಇವಾಗ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ. ದ ಸೆಟ್ ಆಫ್ ಕಂಟೈನ್ the number of integers relatively prime to 2 power 14, the number of integers relatively prime to 2 power 14 and less than 2 power 14 ಅದನ್ನ ನಾವು ಈ ಫಾರ್ಮ್ಯಾಟ್ ನಲ್ಲಿ ಬರೀತೀವಿ ಅಂತ ಹೇಳಿದ್ದೀನಿ. ಅದು ಹೇಗೆ ಸಾಧ್ಯ ಸರ್? 2 power 14 ಅಂದ್ರೆ 16. 16ಗೆ ಯಾವ್ಯಾವ ನಂಬರ್ಸ್ ರಿಲೇಟಿವ್ಲಿ ಪ್ರೈಮ್ ಆಗಿರುತ್ತೆ ಅಂತ ಬರೆಯೋಣ. 1 is relatively prime with 16. Is it? Next, 2 is not relatively prime with 16. 3 is relatively prime with 16. 4 barala. 5 is relatively prime with 16. 6 is not relatively prime with 16 because 6 and 16 are divisible by 2. Next, 7 is relatively prime with 16. 8 is not relatively prime with 16 because 8 divides 16. Next, 9 is relatively prime with 16, no doubt. 10 and 16 are commonly divided by 2, so they are not relatively prime with each other. 11 is relatively prime with 16, no doubt. And 13 is relatively prime with 16. 12 is not relatively prime with 16 because 12 is commonly divided by 2. 12 and 16 are commonly divided by 2. So next, 15 is relatively prime with 16. Observe here, 1, 2, 3, 4, 5, 6, 7, 8. 8 numbers, 8 integers are relatively prime with 16 and less than 16. Is it clear? So on the basis of this concept, I find the number of integers which are relatively prime with 16 and less than 16 are, see here, 5 of 2 power 4 is nothing but 2 to the power of 4 minus 2 to the power of 4 minus 1. Same ಇದೇ ಕಾನ್ಸೆಪ್ಟ್ ಅಲ್ಲಿ ಬರ್ತಿದ್ದೀನಿ. Here p is nothing but 2, k is nothing but 4. So 2 power 4 is nothing but 16 minus 2 power 3. 4 minus 1 is 3. 2 power 3 is nothing but 8. 16 minus 8 is 8. So the 8 integers are relatively prime with 16 and less than 16 ಅಂತ. ನಮಗೂ ಇಲ್ಲೂ 8 digits ಬಂದಿದ್ದು, 8 integers ಬಂದಿದ್ದು. On the basis of this concept ನಮಗೂ 8 ಬರೋದು. So ಹಾಗಾಗಿ the set contains exactly p power k minus p power k minus 1 integers which are relatively prime to p power k. So ಹಾಗಾಗಿ ನಾವು ಇದನ್ನ ಈ ತರ ಪ್ರೂಫ್ ಮಾಡ್ಕೊಂತ ಹೋಗ್ತೀವಿ. I think you are all understand the theorem, hence the theorem. Is it clear? Students, the next theorem is, if n is equal to p1 to the power of k1 into p2 to the power of k2 into p3 to the power of k3 so on, pr to the power of kr is the canonical representation, then phi of n is equal to n into 1 minus 1 divided by p1, 1 minus 1 divided by p2 so on, 1 minus 1 divided by pr. That means if n can be represented as the product of prime factorization, ಅಂದ್ರೆ ನಾನು ನಿಮಗೆ ತುಂಬಾ ಹಿಂದೆನೇ ಹೇಳಿದೆ ಯಾವ್ದಾದ್ರು ಒಂದು ಇಂಟಿಜರ್ ನ ಪ್ರೈಮ್ ಫ್ಯಾಕ್ಟರೈಸೇಷನ್ ಅಲ್ಲಿ ಹೇಗೆ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತೀವಿ ಅಂತ. ಸೊ ಎಕ್ಸಾಕ್ಟ್ಲಿ ಅದನ್ನ ಹೇಳಿದರೆ ಇಸ್ ದ ಕ್ಯಾನಾನಿಕಲ್ ರೆಪ್ರೆಸೆಂಟೇಷನ್ ಅಂತ ಹೇಳಿದರೆ ಅಥವಾ ಪ್ರೈಮ್ ಫ್ಯಾಕ್ಟರೈಸೇಷನ್ ಅಂತಾನು ಹೇಳ್ಬೋದು. ಇಫ್ n can be written as like that, then the number of integers, that means Euler's function. I am going to tell the Euler function, that is the number of integers relatively prime to n and less than n can be written as like this form. n ಗೆ ರಿಲೇಟಿವ್ಲಿ ಪ್ರೈಮ್ ಆಗಿರೋದು ಹಾಗೆ n ಗಿಂತ ಕಮ್ಮಿ ಇರುವಂತದನ್ನ ನಾವು ಈ ಫಾರ್ಮೆಟ್ ಅಲ್ಲಿ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತೀವಿ ಅಂತ ಹೇಳಿ ಪ್ರೂಫ್ ಮಾಡಬೇಕು. ಸೊ ಪ್ರೂಫ್ ಆಫ್ ದಿಸ್ ಥಿಯರಮ್ by data, n is equal to p1 to the power of k1 into p2 to the power of k2 into p3 to the power of k3 so on, pr to the power of kr. Here p1, p2, p3 so on, pr are pairwise prime integers. Pairwise prime integers, they are all prime numbers. Okay, next I consider phi of n. See here, phi of n is nothing but this one, p1 to the power of k1 into P2 to the power of K2 into P3 to the power of K3 so on PR to the power of KR. Is it clear? No doubt this phi is a multiplicative function. So in the previous classes I already told you how phi is nothing but an multiplicative function. ಅದು multiplicative function ಹೇಗಾಗುತ್ತೆ ಅನ್ನೋದನ್ನ ನಾನು ನಿಮಗೆ ಈಗ ತುಂಬಾ ಹಿಂದಿನ ಕ್ಲಾಸಸ್ ನಲ್ಲಿ ಹೇಳಿದೀನಿ. So if phi is multiplicative function, then that can be written as, if phi of m into n can be written as phi of m into phi of n. So on the basis of that, this can be written as phi of p1 to the power of k1 into phi of p2 to the power of k2 into phi of p3 to the power of k3 so on phi of pr to the power of kr. Is it clear? From the previous theorem, phi of p power k is nothing but what? Phi of p power k is equal to p power k into 1 minus 1 divided by p. Is it clear? So on the basis of this concept, this phi of p1 to the power of k1 can be written as p1 to the power of k1 into 1 minus 1 divided by p1. Is it? Similarly, this can be written as p2 to the power of k2 into 1 minus 1 divided by p2 into p3 to the power of k3 into 1 minus 1 divided by p3 so on pr to the power of kr into 1 minus 1 divided by pr. So these are all terms in product. So this can be written as, by rearranging, and I write the terms as p1 to the power of k1 into p2 to the power of k2 into p3 to the power of k3 into so on pr to the power of kr into 1 minus 1 divided by p1 into 1 minus 1 divided by p2 into 1 minus 1 divided by p3 so on 1 minus 1 divided by pr. So this is nothing but n. In the statement itself, p1 to the power of k1, p2 to the power of k2 into p3 to the power of k3 so on pr to the power of kr can be written as n. Therefore phi of n is equal to n into 1 minus 1 divided by p1 into 1 minus 1 divided by p2 into 1 minus 1 divided by p3 so on 1 minus 1 divided by pr. Hence the result. This is the proof of the given theorem. Is it clear? Okay. Okay students, the problems on this Euler's function is, first one, evaluate phi of 900. That means you have to find the number of integers which are relatively prime to 900 and less than 900. So the solution to this problem having two types. ಎರಡು ಟೈಪ್ ನಲ್ಲಿ ನಾವು ಸೊಲ್ಯೂಷನ್ ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬಹುದು. ಹೇಗೆ ಅಂದ್ರೆ ಅವೆರಡು ಟೈಪ್ ನ ಸಾಲ್ವ್ ಮಾಡೋದಕ್ಕಿಂತ ಮುಂಚೆ ಫಸ್ಟ್ ಯು ಹ್ಯಾವ್ ಟು ರೆಪ್ರೆಸೆಂಟ್ ದಿಸ್ 900 ಆಸ್ ಎ ಪ್ರೈಮ್ ಫ್ಯಾಕ್ಟರೈಸೇಷನ್. ಸೊ 900 ಫಸ್ಟ್ ಪ್ರೈಮ್ ನಂಬರ್ ಈಸ್ 2. ಸೊ 2 ಇಂದ ಇದನ್ನ ಡಿವೈಡ್ ಮಾಡೋಣ, ಅವಾಗ ಏನ್ ಸಿಗುತ್ತೆ? 450. Is it clear? Again divided by 2, that gives 2 2s are 4, 2 2s are 4, 10, 2 5s are. Next is this 2 to 5 is divided by 3? Yes, no doubt. 21, 15, 3 5s are. Next further 3 ಇಂದ 75 ನ ಡಿವೈಡ್ ಮಾಡಬೇಕು. ಸೊ 3 2s are 6, 15, 3 5s are 15. Next, 5 5s are 25. That means this 900 can be written as 2 square into 3 square into 5 square. So first method, phi of 900 is nothing but phi of 2 power 2 into phi of 3 power 2 into phi of 5 power 2. We already know that phi of p power k is nothing but p power k into 1 minus p. On the basis of that, this can be written as phi of 900 is equal to, or you can also write p power k minus 1 on the basis of that concept. This phi of 2 power 2 can be written as 2 power 2 minus 2 power 2 minus 1 into 3 power 2 minus 3 power 2 minus 1 into 5 power 2 minus 5 power 2 minus 1. Next, further 2 square is nothing but 4 minus 2 into 9 minus 3 into 25 minus 5. 4 minus 2 is 2 into 9 minus 3 is 6 into 25 minus 5 is 20. That is 2 into 6 is 12. 12 2s are 24. That value is 240. This is phi of 900. Is it clear? So another one type is, first you write the values of P1. P1 is equal to 2, P2 is equal to 3, P3 is equal to 5. ಅರ್ಥ ಆಯ್ತಾ ಹೇಗೆ ಅಂತ? ಇಟ್ ಇಸ್ ಇನ್ ದ ಫಾರ್ಮ್ ಆಫ್ P1 to the power of K1, P2 to the power of K2, P3 to the power of K3. ಆ ಫಾರ್ಮ್ಯಾಟ್ ಅಲ್ಲಿ ಇದೆ. So P1 is nothing but 2, P2 is nothing but 3, P3 is nothing but 5. So next I use the formula, that is phi of n is equal to n into 1 minus 1 divided by P1, 1 minus 1 divided by P2, 1 minus 1 divided by P3, so on. So here phi of n is nothing but 900, that is equal to 900 into 1 minus 1 divided by 2 into 1 minus 1 divided by 3 into 1 minus 1 divided by 5. 900 into 1 minus 1 by 2 is nothing but 1 by 2. 1 minus 1 by 3 is nothing but 2 by 3. Into 1 minus 1 by 5 is nothing but 4 by 5. Next, further 2 450s are 900, 3 150, 3 150s are 450, 5 ones are 530s are 150. That gives 30 into 2 is 60, 60 into 4 is 240. Phi of 900 is equal to 240. ಸೊ ನೀವು ಇವೆರಡರಲ್ಲಿ ಯಾವ ಟೈಪ್ ನಲ್ಲಿ ಬೇಕಾದರೂ ಪ್ರಾಬ್ಲಮ್ ನ ಸಾಲ್ವ್ ಮಾಡಬಹುದು. ಸೊ ಇದು ಕಂಪಲ್ಸರಿ, ಇಲ್ಲಿ ತನಕ ಕಾಮನ್ ಆಗಿ ಫೈಂಡ್ ಔಟ್ ಮಾಡಲೇಬೇಕು. ಅಲ್ಲಿಂದ ಮುಂದಕ್ಕೆ ನೀವು ಯಾವ ಟೈಪ್ ನಲ್ಲಿ ಬೇಕಾದರೂ ನೀವು ಪ್ರಾಬ್ಲಮ್ ನ ಸಾಲ್ವ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಐ ಥಿಂಕ್ ಎಲ್ಲರಿಗೂ ಅರ್ಥ ಆಗುತ್ತೆ ಅಂತ ಅನ್ಕೊಂತೀನಿ. ನೆಕ್ಸ್ಟ್ ಫರ್ದರ್ ಪ್ರಾಬ್ಲಮ್ಸ್, evaluate phi of 5186 and phi of 5040. Take these two problems as homework. Okay, ನಿಮಗೆ ಈ ವಿಡಿಯೋ ಇಷ್ಟ ಆಗಿದ್ರೆ ಲೈಕ್ ಮಾಡಿ ಹಾಗೆ ಶೇರ್ ಮಾಡಿ. ನೆಕ್ಸ್ಟ್ ಇನ್ನ ಉಳ್ಕೊಂಡಿರುವಂಥ ಥಿಯರಮ್ಸ್ ನೆಕ್ಸ್ಟ್ ವಿಡಿಯೋಸ್ನಲ್ಲಿ ಮಾಡ್ತೀನಿ. ಥ್ಯಾಂಕ್ ಯು ಫಾರ್ ವಾಚಿಂಗ್. ಥ್ಯಾಂಕ್ ಯು ಒನ್ ಅಂಡ್ ಆಲ್. ಥ್ಯಾಂಕ್ ಯು.